So we know the density of nitrogen in a tank is 1.5 kilograms per cubic meter when the temperature is 25 degrees centigrade. So what we want to do is determine what the gauge pressure is if the atmospheric pressure is 97 kPa. So let's write down what we know. The first thing is this density is equal to 1.5 kilograms per cubic meter. Our temperature is 25 degrees centigrade. We're going to want to put that into absolute. So we'll add 273 to that to get 298 Kelvin. And we're dealing with nitrogen, so we want to look up what the R value of nitrogen is. And the R value for nitrogen is 296.8 joules per kilogram Kelvin. We also know the pressure of the atmosphere is 97 kPa. So I have two equations that we're going to need for this. Well, the first one is we know that the perfect gas law states that pressure is density times R times T. And then we know that the pressure in our tank is going to be the atmospheric pressure plus the gauge pressure. And so that will give us the absolute pressure in our tank. So instead of writing this as P of the tank, you can also write what's the absolute pressure. So the absolute pressure is going to be the atmospheric plus the gauge. So let's find the pressure. I don't have to rearrange this equation. 1.5 kilograms per cubic meter times 296.8 joules per kilogram Kelvin times 298 Kelvin. So remember, joules and Newton times a meter. Kilograms will cancel out. Kelvins will cancel out. This will be a Newton meter. We have one of the meters cancel out, so we're left with newtons per meter squared. The Newton per meter squared would be a Pascal. And so we are left with 133,000 pascals, or 133 kilopascals. So now we go back to this equation here, because that's our absolute pressure. We want our gauge pressure. So if I rearrange this, my gauge pressure is going to be my absolute pressure minus whatever the pressure of atmosphere is. Because remember, gauge pressure is just telling how far you are from atmospheric pressure. So looking at this, our absolute pressure is 133 kPa. I'm going to subtract from that the atmospheric pressure, which is 97 kPa. And once we do that, if we had a gauge on that, it would be reading that the pressure in that tank is 36 kilopascals.